So let's talk about why all of these are the same. So we just showed that if we're trying to find the slope of a curve could be any kind of function here, we're just going to find the tangent line. So slope of a curve means slope of your tangent line. And so what we did is we just either drew the tangent line and found the slope, or we calculated the slope like normal, y2 minus y1, x2 minus x1. So when it says the slope of y equals f of x, we're just saying that what's the slope of a function, which could be any kind of curve, at some point, which they're calling a, some x value. Okay, so if they say the slope of y equals f of x at a, it means the same thing as if they were to actually write the slope of the tangent line. So you have to correlate slope of a function to being slope of tangent line. It's indirectly known that they're saying slope of tangent line, so you need to know that. So one of the biggest things I would have you write in your notes right now is that slope equals tangent line lines slope. Slope of the curve means figure out the slope of the tangent line. Now they could say the instantaneous rate of change, and that's because rate of change means slope. So back in Algebra 1 and Algebra 2, whenever they said, find the rate of change, which just means the change in the y's over the change in the x's. So when it says the instantaneous rate of change of f of x with respect to x, all they're asking is that you're changing some function's value over the change in the x values. And sometimes people will call that delta y over delta x. Remember, delta means change. And then, oh, look at this one. It leads into this. Now, doesn't this look familiar? Right? Does this look familiar? We had this in the past. But look, they're just interchanging delta x with h. Okay? So what this is doing, what we've done in the past, is pretty much getting you ready to do what we're doing up here. So if all of these mean slope, 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 that means that this is going to equal slope. So when we do that work, now the last couple chapters we did this work and we got an answer and we just kind of circled it and say, hey, there's my answer. Now we're saying that that answer that you got, that you did by doing all your mathematics, that is truly representing the slope of the function. So now when we finish, that will give us the slope of our tangent line. So let's recap here. Slope of a function means slope of tangent line. Tangent line means we would actually draw a tangent line where it hits our function's curve at one spot. What we're also asking about that same spot is rate of change, but rate of change means slope. Okay, and then when we did all this mathematics in the past, the answer technically is the answer to our slope. So in this one, I ask you to draw a graph of the derivative. So the first thing you want to do is find the derivative. And the derivative is found by finding the slope of your tangent line. So let's go ahead and sketch this. We know we've got a point at 0, 0, 1, 1, negative 1, 1, 2, 4, and then negative 2, 4. Oops. Okay, so we want to just draw any kind of graph of the derivative of f of x equals x squared. And it doesn't really say where at, so we're just going to pick a point. So let's say we pick this point, and we drew a tangent line just through this point. So what we're going to do is we're going to try and find rise over run, but we need 2 points to do rise over run. So let's pick this point at 1, 1, and then this one at 2, 4. So we're going to rise up 3 and go over 1. So if our slope is 3 over 1, that means that the derivative is going to be 3, which means we're going to graph the derivative, and when we graph a constant function, it is going to be a horizontal line at that exact same number. So notice that a squared function, which is a parabola, its derivative is a constant function, a horizontal line. Similarly, let's look at this one. Draw a graph of the derivative. Well, first we need to figure out the derivative by finding the slope of our tangent line. So let's first graph for x. Intercept is at 0, up 4 over 1. Now, how do I find the slope of a straight line? Well, kind of looking right at it, the slope would be 4. So if the slope is 4, that means the derivative is 4. And if the derivative is 4, that means we have to graph that line, y equals 4, which is also a constant. Alright, let's take a look at the next one here. So this one's already giving you the graph at a couple different points, and they're just asking what's the derivative going to be, sign value wise. Well, remember that derivative means slope of tangent line. So let's look at part A. If you look at the point A here, and if I were to estimate a slope of a tangent line, you know it's going to be going downward because the line itself is going downward. So we would say that A has a negative derivative, and this is because the slope of the tangent line is negative. Alright, now B, same kind of reasoning, but we're going positive. So B has a positive derivative because the slope of the tangent line is positive. And let's look at C. C is at the very top of a hill. And so at the top of the hill, if I were to draw my tangent line, it would go straight across. And so what's the slope of any line that's horizontal? So we're going to say C has a zero derivative, because the slope of your tangent line is 0. So remember to draw the tangent lines and then figure out what the sign of the slope would be.